Alright, so I think I'm recording now. I've been having problems with this program freezing up, so I thought I might start making some blooper reels because when it freezes up it still continues to record and you kind of hear me complaining about it. Maybe that's not a good idea to record. Alright, let's let's take a look at problem number 6. They give us a function and they ask us to find the inverse and determine if that inverse is a function. Well, I can see I'm familiar. I have this library of functions, and one of the functions in that library is the cube function, x cubed. So I can see that this function f is just a transformation of that. It has, if you take x cubed and if you do a vertical stretch by a factor of 2, and then next if you shift that result down 1 unit, then you have transformed this parent function of x cubed into this function of f. Well, I know what x cubed looks like. Here's a rough sketch of x cubed, that it goes up like this and x like that. that it's like that it's an odd function. A vertical stretch by a factor of 2. Let's see if I can, that's stretching the graph where the x coordinates are staying the same, but it's stretching the graph away from the x-axis. And then to shift this whole graph down 1 unit would just look like that. So clearly this initial relation is a function. It passes the vertical line test, but it is also, it achieves the title of a one-to-one function because it passes a horizontal line test as well. So I expect that this function, its inverse, will also be a function because this function is a one-to-one function, and only one-to-one functions have inverses that are also functions. The technique for finding this inverse function is to switch. The idea of an inverse switches the domain and range. So I'm going to write this just using my familiar x and y notation. And since the domain and range switch, I'm going to switch the variables x and y. So now I'm going to solve this equation for y. So on the right hand side I have two terms. The term that has my variable of interest, this y, is the first term. So to get that term by itself, I'm going to add 1 to each side of the equation. Now on the right hand side I have a single term that has 2 factors. I want to get that y cubed by itself. So I'm going to divide both sides by 2. 2 divided by 2 is 1. So I have y cubed is equal to this x plus 1 over 2. Now to solve for y, I need to take the cube root of each side of the equation. When I take the cube root of y cubed, I get y, and over here I have the cube root of x plus 1 over 2. Now that's going to be fine. I don't have to continue to rationalize denominators, especially for these indexes that are higher than 2, higher than a square root. So we can sit here and say that this is our inverse function. But for those that just want to remember or have forgotten You know, it could be that you take a math class someday where they do expect you to rationalize the denominator. So how would we do that? Well, it's all about recognizing that index. Here, I can't have a denominator underneath the square root and stuff. So in order to take a base out from underneath the radical, the exponent has to be some power of this index. I'm going to multiply by the number 1, and we've seen that many times in algebra and arithmetic that we do this. But I'm going to write 1 as 4 over 4, or 2 squared over 2 squared. Now, why am I doing that? Well, when you multiply fractions, you multiply straight across the numerator and straight across the denominator. So here I have this 2 squared, which is just 4. And I'm going to multiply it times this binomial. I'm not even going to bother to distribute it. I'm just going to leave it in factored form. My denominator now, 2 to the first power times 2 squared, is 2 to the third power. So now notice that I have an index here of 3 and an exponent of 3, and now I can take the cube root of the numerator and I can take the cube root of the denominator separately, and the cube root of 8, the cube root of 2 cubed is 2. So it is possible that that if you ever had another math class that the professor would expect, or if you were just checking answers in the back, say of some textbook, that it would express our final answer like that. Okay, so either one of those is acceptable, and this first one's fine with me. Alright, so I hope that helps. So to be clear, here was the original function f. I know it was a transformation of my cubing function. I know that this cubing function is a one-to-one function. So when I find the inverse, I know the inverse is going to be a function. And this is the inverse function, and this notation is this negative 1 is not an exponent. This is just the title, the name, the way that we name an inverse function. Alright, so I hope that helps.